Today I'm going to do a demo of Private AI's new Analyze Text endpoint and dive into our co-reference resolution features. These are new features that were released in version 4.1 and 4.2 of the Private AI redaction platform. Designed to enhance our entity recognition functionality, the Analyze endpoint provides advanced analysis of entities in text. Broadly speaking, this functionality has two components, entity analysis and relation detection. Relation detection can be broken down into co-reference resolution and relation extraction. What this means is that we can now utilize custom redaction or validation on detected entities. This can be useful for doing things like age rounding, date bucketing, or simply to trigger different workflows based on the types of entities present in the analyzed text. Within this block of code, we are performing standard redaction and using the Analyze endpoint to do numeric bucketing on ages. We have a simple set of calls that are supported by our Private AI thin client. In the code, I've put together a custom handler that rounds numbers to the nearest tens and prints the final redacted result. We have a set of patient notes that contain multiple pieces of health information and personal information. For the purpose of this first demo, we're going to redact everything except for drug names and age, and then round the ages to the nearest 10. Let's see what our output looks like. Here we can see that we have identified multiple pieces of PII and PHI. We've also redacted everything except for drug name and age. And the age has been rounded to the nearest 10. This is a quick example of how you can redact information while maintaining critical utility of data within the datasets. I'll now move on to our more advanced demo of co-reference resolution and relation extraction. What I have on the screen is a simple example that spans 3 separate sets of patient notes. These examples are pretty chatty. They have too much information and reflect on how people talk when they speak with their trusted medical professionals. The code is pretty simple as it's making a single function call, but the data you get back is very powerful. I've split these conversations out and I will run them one at a time to show how you can slowly build up a dataset of interrelated entities. The first set of notes describes a patient that is about to take a trip for their birthday. They regularly visit Toronto General. We can see that they have been prescribed some medication and they've provided some details about family and clearly they're excited about their trip. Let's see what our API returns. In the block below, we are parsing the response. We print all of the related entities and we print the unique co-reference IDs that we've built for each. We show where multiple entities share the same co-reference ID, or in other words, where the same person is referenced in different ways. Using the relation extraction functionality, we're also showing where relations have been built across entities. The first thing we can see is multiple references to our doctor, Dr. Lee. Next, we can see the different ways that we talk about our patient, Michael. At the bottom of that, we can see the other entities that are linked to Michael. We can see his birthday, and we can see that he shared information about his brother David, who's also linked to him. Scrolling further down, we can also see that David is linked to Michael. We can additionally see that David is linked to the multiple locations he's listed, places he's lived or lives now. I'll add a bit more text to simulate a second visit and update the list of notes. In the second conversation, our patient has once again met with Dr. Lee to discuss the trip and provide updates on their health. In this conversation, we can see Dr. Lee referenced in a new way, and we can see that Michael has declared where they live. In the text, we can now see that Dr. Lee has a new reference in their co-reference ID list. We can also see that Michael has a new related entity with their location in Toronto. Lastly, we will add one more set of patient notes to show another way where we can link entities with this new feature. We have a new patient, Emily, that is seeing a Dr. Kim. Emily is a new Canadian and is excited to see how our healthcare system works in action. Within the text, we can see our 2 new references to Dr. Kim. We can also see the various ways that we have addressed Emily. We can see the link between Emily and her brother Alex. We can also see that Emily is both a Jamaican and a Canadian. And lastly, of course, we can see that Alex is linked to Emily. With this new feature, you can start to imagine how we can open the door to some pretty powerful research outcomes with data. We can see how our co-reference resolution and relation extraction features can be used to build up a robust and research-ready dataset out of messy, unstructured data. We can start linking patient mentions across datasets over spans of time, mapping relations between diseases, treatments, family histories, and more. to support strong, evidence-based healthcare decisions.